Hello everyone. So the previous video we have discussed about random access protocols. So in this tutorial, we're going to discuss about controlled access protocols. So as the name suggests, right, the controlled access means if any one station wants to transfer data, then it has to get the permission or authorization from other stations. So there are three popular controlled access methods: reservation, pooling, and token processing. They are the very popular controlled access protocol methods. So reservation, the first one, um, if have a data to transfer, right? Um, the time slot, the total time period will be divided into a number of slots or intervals, right? So you have to reserve how many slots you want for your data transmission. So and this request has to be approved by the other participating stations in the network, right? So this method is called reservation. So if there are n stations in the system, then there are exactly n reservation mini slots in the frame, right? So each mini slot belongs to a station, right? So whenever your station needs to send a data frame, and it makes a reservation in its own mini slot. So this is the basic idea of uh, reservation, right? Uh, the second method is polling, right? So polling uh, is the kind of uh, server client server architecture, right? One-way communication. So in which one device is designated as a primary station, right? Server, like, right? The other stations are secondary stations. So all the data exchanges must be made only through primary station, right? The primary device control the link, data control, data transmission, everything, and the secondary stations has to follow its instructions, right? Secondary stations cannot control the link or cannot control the transmissions. Okay? So secondary stations has to obey the instructions given by the primary stations, right? So primary station is always the initiator of a session, right, and the terminator of the sessions. So you cannot select the channel or link whenever you have data, right? So this is the one major drawback of polling method. So when the primary station asks you whether you have any data to transfer, then only you can uh, acquire the link and start transmit your data, right? So the select function is used whenever the primary station has something to send, right? So if the primary is neither sending nor receiving the data, it knows the link is available, and if it has something to send, the primary device sends it, right? Whereas second function is poll function. Poll function is used by the primary device again, right, to solicit information transmission from the secondary devices. So it will uh, establish the communication between the secondary devices by using the polling function, right? The third method is token passing. So token passing, the stations in the network are organized in a logical ring, right? Logical ring. So in other words, each station must exactly have two neighbors, right? Two neighbors, one predecessor and one successor, right? The predecessor is a station which is logically before the station in the ring, right? The one before your device. Successor is the after you. So successor is the station after your device, right? So token passing is very simple method. Uh, So yeah, token will be circulated among the devices, right? So whenever you have a data to transmit, you need to acquire the data. So whenever you have the token, right? you can acquire the token until the data transmission is completed, right? So once the data transmission is over, you can release the token to your successor, right? So this is how token passing will be implemented, right? So there are different types of token passing method. So token passing can be either implemented by a physical ring or logical ring, right? So this configuration can be implemented by physical implementation or logical wire, right? So uh, there are different variations of token passing. So instead of having a single line or logical ring, right? We can have a dual ring or bus-based bus-shaped ring topology, star ring topology to uh, improve the reliability, right? Because so with only uh, single logical ring, right? If the link fails or breaks, right, the entire network will be collapsed, right? So if the ring in the particular topology is failed or break, right, the entire network cannot be communicated because each device will have exactly two neighbors, right? So instead of you having a single logical ring, you can have dual ring like this or bus-based ring topology, star-based ring topology, right? So the dual ring topology is based on primary and secondary. So the pink colored arrows indicate the secondary ring or auxiliary ring, right? The primary ring will only be used for communication. If primary link fails or breaks, right, then you can use the secondary link for emergency purpose, right? Whereas the second method, bus ring topology, also called as broken bus, right? When the station has finished sending data, it releases the uh, token and insert the address of the next uh, device in the ring or successor, right? So only the station with the address matching the destination address of the token gets the station gets the token and access the shared media. Whereas in the final one, star ring topology, physical topology is like a star. There is a hub, central device, controller device that access the connector, and all the communications will be uh, established only through the central control device hub, right? So adding removing stations from the ring is very easier, right? This topology is still used in the token ring LAN designed by the IBM, right? So token passing. So the main concept is if you want to transfer the data, first you have to wait until you receive the token, right? Token for your right? So your token will be received from the predecessor, and once your data transfer is over, you can release the token to your successor. Right? This is how token passing will be implemented. And the next, we'll move on to flow control and error control. Right? So how much data sender can transmit before receiving the acknowledgement. So flow control, see, uh, uh, in case of wired medium, right, or physical medium, flow control during the connection establishment phase, right, that the receiver will intimate the sender that I can able to receive only this much amount of data, right? So during the connection establishment phase, it will send the acknowledgement. So along with the acknowledgement, it will indicate the capacity of its memory, right, or transmission rate. So I can able to receive only 100 Mbps, say for example 100 megabits per second. Right? So I can able to receive at per second 100 megabits processing speed or the limited memory. I have only limited memory to store the incoming data. So accordingly, you can set your transmission rate. So flow control is the process of setting the procedure used to restrict the amount of data, right? Data that the sender can send before waiting for the acknowledgement. So this is called flow control. Whereas error control is a two-step process, right? First, you have to check whether there is any error in the received data, right? Then, if any error is occurred, the received data, then you have to correct the error or you have to request for retransmission. There are two methods, right? Error detection plus error correction is the one method, or error correction plus retransmission. You can retransmit the sender to sorry, you can request the sender to retransmit the particular frame, right? Whereas error detection plus error correction, you can have your own methodology to correct the error, right? Automatic repeat request. So anytime an error is discovered in the exchange, right, then you can request the sender to retransmit the data, right? So uh, there are three major uh, error control, flow control mechanisms: stop and wait, right? Go back in, and selective wait. So in this video, we'll talk about stop and wait, and in the next video, we'll we'll talk about go back in and selective repeat. Yeah, stop and wait. Uh, as per the name, stop and wait, right? So stop and wait automatic repeat request. This is very easiest and simplest flow control mechanism. You have to stop after sending each data frame, right? So after sending one data frame, you have to stop the transmission and wait for the acknowledgement, right? So once you have transferred the first frame, stop the transmission and wait for the acknowledgement. So each frame should be acknowledged before transmitting the next frame, right? So out of order frames and erroneous or corrupted frames are discarded, and no acknowledgement will be sent for those frames, right? So timers will be there, right? So within the timer expires, if you don't receive the acknowledgement, then automatically the sender will retransmit the particular frame, right? So it's a very simple uh, protocol, right? So this is the timing diagram for stop and wait normal operation. So initially sender will start transmitting its first frame. So upon receiving the frame 0, receiver will send the acknowledgement. So the acknowledgement will be numbered like the frame received plus 1, right? Because it is expecting the frame 1. So acknowledgement for 0. Now it is expecting frame 1, right? So again the sender will transfer the next frame. Then acknowledgement 0, right? If the uh, frame is corrupted or erroneous, then it will send the acknowledgement, right? So see in the second case, if a frame is lost during the transmission, right, the sender will not receive that um, acknowledgement for the particular frame. So if the timer expires, timeout happens, the sender will retransmit the particular frame again and wait for the acknowledgement, right? Wait for the acknowledgement. So this is how stop and wait protocol will be implemented, right? The only drawback is uh, the efficiency or utilization of the bandwidth is pretty much low, right? Only one frame can be transmitted at a time, so the efficiency is very much low when compared to the go back and other protocols. So the alternative solutions or alternative methods are to go instead of transmitting single frame, you can group multiple frames together and transmit, and wait for the acknowledgement, right? So this is what happens in the other protocols. Go back in and selective repeat protocols. So in the next video, we'll talk about uh, go back in and selective repeat protocols. Right? Thanks for watching. So if you have any question, please post it in the comments. Thank you.